Okay, so we're going to talk today about section 8.2, which is the special right triangle. And in the special right triangles, we have two patterns that we need to observe, and that is the 45-45 90-degree relationship and the 30-60 90-degree relationship. So if you look here, we're going to first talk about the 45-45 90. In the 45-45 90, you notice that you have two side lengths or two legs of the triangle that are the same length. And that, of course, is because you have two identical angles. So the relationship between the leg and the hypotenuse is going to be 1 to square root 2. So if I was going to write that ratio of leg here to hypotenuse, then it would be equal to 1 over the square root of 2. And I'm going to use that ratio when I'm finding missing sides in order to determine what the actual missing side is. So if you look down here, we'll start with the first one and ask us what's the value of the variable. And in this case, the variable is h, and of course it is the hypotenuse. So I'm going to set my ratio up for my given triangle as leg over hypotenuse, which is 9 over h. And then I'm going to use my scale factor or my relationship ratio here, which is also leg over hypotenuse. Okay, so when I do that, I'll cross multiply and I'll get 1 times h equals 9 times the square root of 2. Therefore, the hypotenuse is equal to 9 times the square root of 2. We'll do the same thing over here, and again, x is the hypotenuse, so I'll say leg, which is 2 times the square root of 2 over the hypotenuse, which is x, and then I'll use my ratio here, which is leg over hypotenuse, so that's 1 over the square root of 2, and then I'll cross multiply. I'll get 1 times x equals 2 times the square root of 2 times the square root of 2. So square root of 2 times square root of 2 is the square root of 4, which is going to be 2. So x is going to equal 2 times 2, or x is going to equal 4. So in this situation, x is going to equal 4. Okay, so let's go down here and see if we can do it with this word problem. So if we look at the word problem, it reads, what is the length of the hypotenuse of a 45-45-90 triangle that has a leg of 5 times the square root of 3? So if we're going to imagine this triangle, we're going to imagine that the leg of this triangle is given at 5 times the square root of 3, and we're looking for the hypotenuse. So I'll say I put leg over hypotenuse, which is x, and then I'll use my 1 over the square root of 2, which is leg over hypotenuse, and then I will cross multiply. So 1 times x is going to equal 5 times the square root of 3 times the square root of 2. So that will become x equals 5 times the square root of 6. And that's how we use the leg over hypotenuse ratio to find missing sides. The next example, we're actually given the hypotenuse and we're looking for the leg. So we can still use the same setup. We'll say leg over hypotenuse is going to equal leg over hypotenuse. But when I cross multiply, I'll notice that I will get the radical with the variable. So that's going to be 1 times 6 is going to be equal to x times the square root of 2. Okay. 6 equals x times the square root of 2. We'll divide by the square root of 2. And 6 over the square root of 2 will equal x. Problem is I'm not allowed to have this radical on the bottom or in the denominator. So I will have to rationalize the denominator or get this radical out. And the way I do that is by saying 6 over the square root of 2, and then I multiply by the square root of 2 over the square root of 2. Now this root 2 over root 2 is equivalent to 1. And the identity property says that I can multiply anything by 1 and still get the same thing and not change the identity. So what I need to do is say 6 times the square root of 2, and then the square root of 2 times the square root of 2 gives me 2. Now I've rationalized my denominator. If I reduce, I get 3, right, times the square root of 2. So my side length is going to be 3 times the square root of 2. And next one, we have the length of the hypotenuse is actually 10, and we're looking for one of the legs. Okay, so we say if this is the hypotenuse, and this is 10, and my legs are x and x, so I'll say x over 10 is going to equal 1 over the square root of 2. So I have the square root of 2 times x equals 10. I'm going to divide by the square root of 2, and I get 10 equals, or x equals 10 over the square root of 2. In order to get rid of that denominator, I'm going to say square root of 2 over square root of 2, and I'll get 10 times the square root of 2 over 2. And as before, I'll reduce it, and my side length, x, will equal 5 times the square root of 2. Okay? And on your homework page, you'll see that 7 through 14 all deal with the 45, 45, 90 triangle. Okay? Go back and pick up this word problem right here. A high school softball diamond is a square, which means it has right angles at every intersection, and the distance from the base to base is 60 feet, so all of the sides will be 60 feet. To the nearest foot, how far does the catcher throw from second to home? Okay, so we're looking for the hypotenuse. So I'll say leg over hypotenuse is going to be equal to 1 over the square root of 2. And so D will equal 60 times the square root of 2. Now, in order to find what that is to the nearest foot, I'll have to actually punch the square root of 2 into my calculator. And 60 times the square root of 2 is approximately 85 feet. Okay, so that gives you your 45, 45, 90 triangle. Now the other pattern that we need to look at is the 30, 60, 90. Now the 30, 60, 90 is a little bit different because on the side where we have 90 and 60, we have the shorter leg, which will be equivalent to 1. On the side where we have 30 and 90, we have the longer leg, which is going to be equal to the square root of 3. And then on the hypotenuse side, we have 2. So if I were to say my ratio was shorter leg to longer leg to hypotenuse, then it would be 1 to root 3 to 2, and that would be an extended ratio. So I would have to pick the two values needed in order to solve. So when I come here to the first one, I'm looking for the value of D, which is the shorter leg, and I've been given the value of 5, which is the longer leg. So I'm going to set this up as the shorter leg D over the longer leg 5, and then I'm going to use my ratio of the shorter leg, which is 1, over the longer leg, which is the square root of 3. And as I cross multiply, I will get D times the square root of 3 equals 5 times 1. My next step would be to divide by the square root of 3, and D will equal 5 over the square root of 3. Of course, we'll have to rationalize that, and if we do that, we'll get 5 times the square root of 3 over 3. So D will be 5 times the square root of 3 over 3. In our next question, though, it asks us to find f, which is the hypotenuse. Now, when given the option of using a calculated value or a given value, we always want to use the given value just in case we've made an error in the calculated value. So I'm going to go back and use my original 5 and f. So I'm going to say long leg, which is 5, over f, which is hypotenuse. So I'm going to use long leg, which is the square root of 3, over 2, which relates to my hypotenuse. So once I cross multiply, I get 10 equals the square root of 3 times f. Okay. My next step, of course, is to divide by the square root of 3, and f will equal 10 over the square root of 3. So we'll rationalize that, multiplying by square root of 3 over square root of 3, and f will equal 10 times the square root of 3 over 3. And I would probably leave this as 10 times the square root of 3 over 3, since there's no easy way to divide that. That would end up being a repeating decimal or a fraction. Okay. Let's do a word problem. An artisan makes pendants in the shape of equilateral triangles. The height of each pendant is 18 millimeters. So this is the height or the altitude. What is the length of S, or the sides, for each of these pendants? Okay, well, this is an equilateral triangle, which makes each of these angles 60 degrees. Okay, so what we actually have in this situation is a 30, 60, 90 triangle. So if we have a 30, 60, 90 triangle, and I do right here, I have a 30, 60, 90, and of course my short leg would be my 60, and long leg would be here, and so this would actually be 18 millimeters right here. And the hypotenuse, right, is going to be my side. So I'm going to say long leg, which is 18, over hypotenuse, which is S, is going to be equal to long leg, which is square root of 3, over 2. So I'll cross multiply here, and I get 18 times 2 will give me 36 equals the square root of 3 times s. So I'm going to divide by the square root of 3, and s will equal 36 over the square root of 3. At this point, I'm going to multiply it by square root of 3 over square root of 3, and I get 36 times the square root of 3 over 3. Now I can reduce that. 3 will go in here 12 times, so it's 12 times the square root of 3. That would be my final answer. Now, this question says, suppose the size of the pendant are 18 millimeters. Well, that changes our story just a little bit, because now I'm looking at my triangle, and instead of the altitude here, it's going to actually be the side, which is going to be S, is going to be 18 millimeters. So now it wants to know what is the height, which is going to be here. Okay, so I'll say H over 18, right? And again, that's still root 3 over 2. But now I have 2H equals 18 times the square root of 3. When I'm simplifying here, I'm going to divide by 2, and h is going to equal 9 times the square root of 3. Okay, and that's how you would do the story problems for the 30, 60, 90 triangle. And as you get to the homework problems, you'll notice that 15 through 20 are your 30, 60, 90 practice problems. So go ahead and take a minute to do those practice problems, and then come to class with your questions.